So you're going to get some more information when you go through the actual notes, but let me just give you an overview here of some of the things that you have to keep in mind when working with multiple charges. Now, hopefully you have a pretty good handle on basic ionic bonding, on how to figure out the charges of your ions and crisscross them and write names and write formulas and stuff like that. But we're going to take it a step further and deal with some of these funny elements that are found in the D block, not all, but some of the elements in the D block and the low P. So if you look at the periodic table, most of the P block follows the rules and they make the charge that you expect them to make based on their group. However, if you look down like at lead or at tin, they're low in the P block and they make weird, or they kind of don't follow the rules. They have weird options here. They might make a +2 or a +4 charge for both of them. So either you memorize them or you look on the periodic table that might give you the charges, but there's really no looking at the periodic table that doesn't give you charges and easily predicting what they do. So you kind of just got to look them up. So let's talk about iron here. Iron can make two charges, +2 or a +3. It's one of these weird guys here. It's a D block element that doesn't follow the rules. So it can make either a +2 or +3. Now chlorine is a P block element that's not one of these low P's. It's just a normal P block. It's in group 7, so it has 7 valence electrons. It needs one more to make 8, and then it'll get its octet. So chlorine is always looking to gain 1, but iron is either going to give away 2 or give away 3. So when iron and chlorine hook up, they're going to make 2 different possibilities for formulas. If you crisscross the 2 with the chlorine, you're going to end up taking this +2 and putting the 2 down here. And then the -1 from the chlorine ends up down here. We really don't write that. We just write FeCl2. So that's one option. But if iron's making a +3 charge, we end up putting a 3 down here and the 1 over there. So we end up with FeCl3. So again, 2 different formulas depending on which of these charges iron ends up making. Now let's look at lead. Lead is a +4 and a +2. Nitrogen is a P block element, but it's not one of these low P's. It's a normal P. It always makes a -3 charge. So when you crisscross these, you have a couple possibilities again. If lead's a +4, nitrogen always makes a -3 nitride ion. The 3 goes here and the 4 goes there. And we end up with Pb3N4. But if lead makes a +2, the other option, -3, crisscross them, we end up with a 2 and a 3, so now we have Pb3N2. So again, 2 different formulas depending on the charges that these D block or low P elements make. And it's not all D block. Like zinc always makes a +2. Silver always makes a +1. So some of these D blocks are dependable. You just kind of got to look up what they make or memorize them. But a lot of them do make these multiple charges. They do these weird things. So they could make more than one charge. So if I was talking about these elements, then I would have a problem because this is iron chloride and this is iron chloride. Well, which one am I talking about? This is lead nitride. This is lead nitride. Which one am I talking about? So we need another little detail to figure out which element or which compound is which. So we're going to talk about how to use Roman numerals in a minute. Here's iron. Iron's hooked up with chlorine. Here's iron. Iron is hooked up with chlorine. So again, if I just say iron chloride, I don't know which is which. So what I'm going to do is use Roman numerals. Now Roman numerals are awesome because they tell you the charge of the ion. In parentheses, you will see the charge. Not how many are in the formula, but the charge. I love it when I see Roman numerals because it tells me the charge. So in a minute, we're going to go and look at some names with charges in Roman numerals. So right away, I know that this is an iron +2. This is a tin +2. This is an iron +3. This is a tin +4. Love to see Roman numerals because they give me the charge. So let's look at it from the reverse before we go back to that page. Here's my 2 irons. In this case, I got to figure out what charge iron makes so I can know what Roman numeral to put in here. So what I'm going to do is I'm going to uncrisscross. I'm going to take the 2 and I'm going to put it up on top of the iron. The metals always come first, are always positive, so +2. I'm going to take the imaginary 1 and put it up above the chlorine. Anions are always negative. So I'm going to put the -1 up here. So I've got a +2 for iron and a -1 for chlorine. Those are my charges. Now chlorine does make a -1, so we're good to go here. I'll show you what happens when this is wrong. But iron's going to be a +2, so I put a Roman numeral 2 in there to indicate that this formula, FeCl2, is called iron with a Roman numeral 2 in parentheses. Now let's look at iron with a Cl3 after it. This, if I uncrisscross it, gives me the +3 on top of the iron. The -1 comes from that imaginary 1 down there. This is correct. I'm good to go. So this iron is going to make a 3. So I put Roman numeral 3 in parentheses. Iron 3 chloride. Iron 3 chloride is this guy up here. So this is iron 2 chloride. This is iron 3 chloride. Roman numerals tell us what the charge is, so it makes it nice and easy. Or if we figure out the charge, then we know what Roman numeral to put there. Now let's do these guys over here with some lead. So I'm going to uncrisscross my charges. I'm going to put the 3 over there and the 2 over there. The metals always come first, so positive always comes first. Oops, 2. And the negatives always come afterwards. So Pb +2 and -3. So if I was to write the formula here, I know this case lead's a 2, nitride's always a 3. And over here, if I crisscross or uncrisscross, I put the 3 there and I put the 4 there. So it's +4 and still a -3. This is right. So now I know to put 4 in parentheses, lead 4 nitride. So again, we use Roman numerals to tell us which is which, because if I just called this lead nitride, I wouldn't know if it's this one or this one, because this is also lead nitride. So this is lead 2 nitride, this is lead 4 nitride. Now, quick, before we leave this is a 3. Notice that this is not a 3. This is a 3. This is not a 3. The Roman numerals does not, this is huge, it's very important. The Roman numerals does not tell you how many ions are in your formula. That is wrong. The Roman numerals tell you the charge. Once you know the charge, then you know how to crisscross it and figure out what, how many ions are in there. But this is not the charge. I'm sorry. This is not the number of ions. It's not 2 ions in there. This Roman numeral is the charge. All right, let's see this in action here. Now, there's one little catch. We always have to check our anion's charge. So SNO, let's look at a few examples here. Tin and oxygen bond on a 1-to-1 ratio. So if I was to uncrisscross this, I would end up with SN with a +1 charge, positives always come first, and oxygen with a -1 charge. Now, oxygen doesn't make a -1 charge. I'm checking my anion. This is wrong. When I realize that it's wrong, it's not a big deal. I quickly fix it. I'm going to multiply everything by 2. So this is going to become SN +2, and this becomes SN -2, or oxygen -2. That is right. Tin with a +2 and oxygen with a -2. So I keep changing it until I get oxygen to be correct. Once oxygen is correct, then I magically know the tin charge. So this is tin 2 oxide. SN +2 bonds with O -2. If I crisscross them, it's SN2O2, and then I reduce SNO. Now let's look at iron over here. So iron is going to have a 1-to-1 ratio with phosphorus. So I want to uncrisscross them. Fe is +1, and phosphorus is -1. Now this is the problem, because phosphorus isn't normally a -1. Phosphorus is a -3. So that means, and I figured that out by looking on the periodic table, by the way, that means I'm going to multiply all this by 3. So I'm going to have Fe +1 times 3 is +3. Phosphorus -1 times 3, I'm going to distribute, that's -3. Now phosphorus is correct, so I'm good to go. I now know the charge on iron. Iron's +3. And if I look at Fe +3 and P -3, I look at that, it's a 1-to-1 ratio, so I write FeP. So uncrisscross them to figure out the charges. Normally they're going to be okay, but every once in a while you have to check your anion, because your anion might have the wrong charge. And if it does have the wrong charge, just quickly multiply until you get the right charge, and there you go. You magically know the charge on the metal. Finally, writing formulas from ions with multiple charges. This is super easy. All you have to do is look at the Roman numeral, get all excited because you immediately know the charge. You should either look up or start to remember some of these charges of the nonmetals. Use the periodic table. Oxygen's in group 6, so it always makes a -2. Fe's +2, oxygen's -2. That looks like a 1-to-1 ratio to me, so that's just FeO. So iron 2 oxide, FeO. Notice again, quick little note, there's only one iron here, but yet the Roman numeral's 2. This and this are not the same thing. This tells you the charge. This tells you that iron's a +2. And then you use that, +2, -2, crisscross it, reduce, to get the formula. All right, iron with a 3. So we're going to look at iron +3. Oxygen has got a -2. Crisscross them. The 2 goes down here, the 3 goes there. And then rewrite it nice and neatly, Fe2O3. Tin 2 sulfide. Tin's got a +2. Sulfur, you look on the periodic table, it's in group 6. It also makes a -2 charge. 2 and 2 looks like they cancel out. That's my formula, SNS, 1-to-1 ratio. Now, what if tin's a +4? Sulfur's a -2. Watch what has to happen here. I crisscross them. I put the 4 down there and I put the 2 there. Now I've got SN2S4. That looks to me like it's not the simplest whole number ratio. I can reduce that. So then I'm going to hit this one and make it a 1, and this one becomes a 2, and then I have SNS2. There's my formula there. Now let's look at mercury 2 chloride. Mercury 2 chloride. All right, let's start off here. Mercury is a +2, and chlorine's a -1. Chlorine always makes a -1. So if I crisscross them, I end up with HgCl2. That's different than if I saw mercury 1 chloride. Hg +1, chlorine -1. That's a 1-to-1 ratio. It's HgCl. Now this, how many mercuries, happens to match that, but that's just a fluke. Over here, it's a 2, but there's still only 1 mercury in there. So it's not the number of ions in the formula. It's the charge. All right, lead 4 oxide. Pb +4, oxygen -2. Crisscross them. You get Pb2O4. Looks to me like that can be reduced. It's not the simplest whole number ratio, so this becomes a 1 and a 2. So PbO2. That's lead 4 oxide. Over here, lead 2 oxide. Pb +2, oxygen still makes a -2, always, always, always. That looks like a 1-to-1 ratio to me, so I'm just going to write PbO. Finally, chromium with a +3 charge. Nitrogen, look on the periodic table, it always makes a -3. That's a 1-to-1 ratio, Crn. But if chromium makes a +2, different situation here. Nitrogen makes a -3, crisscross them, you get Cr3n2. So Roman numerals tell you the charge. We need to use them because sometimes some of these elements, D block or low P, they make more than one charge. And then we can make different formulas from them. So we have to know the charge that we have, and that comes from the Roman numerals if we're given the name. And then we can write 2 different formulas based on the charges that they make.